My name is Michael Wiltbank. This is my demonstration of my 4-bit microprocessor using Logisim. I learned a lot during this final. It was pretty interesting, and I hope I don't stumble over my words. I tend to get nervous while recording things. So I'll go ahead and initiate my, oh, I gotta click on Logisim before it works. There we go. This is initiated my microprocessor. So the counter is running by a clock that goes through the prom for the code, and that in turn is sending out two 4-bit numbers, one going into my instruction decoder and one going into my multiplexer. The instruction decoder is depending on the 4-bit number coming in, is picking an instruction that's going out and choosing whether or not we're going to be selecting the multiplexer to send the 4-bit number to the register file, whether or not the register file is going to be sending it to the ALU or to the ASCII display. And as you can see here, the ASCII display is running through and it's working. We got hello brother Davies, 3 plus 4 equals 7, 3 times 3 equals 9. And then we got the two examples of the 4 minus 3 equals 1, which I'll get into a little bit more later, explaining the software subtract and also the hardware subtract. The multiplexer, it said that we didn't have to. It said you're not required to build it. I went ahead and did anyways, just because I kind of struggled with them last time. So I also built the 2-to-1 multiplexer and the 4-to-1 multiplexer that is used in the ALU. But we'll go ahead and look at the register file, this subcircuit. We got our 4-bit number that comes in. We got a write enable that lets it, puts it into effect where it's going to work, and then we can of course select between the register 0 or the register 1 so that we can store those numbers as the clock comes with its comes through, determining where it'll go. And then each of these has another subcircuit. We've got the 4-bit register, and that in turn has a 1-bit register on each of these. Same thing with just the load and the clock that'll have it go through. Looking at the 1-bit register, I went ahead and built the 2-to-1 multiplexer, and I used the D flip-flop since the instructions said that we could, just to simplify it. And again, those just come in and you can store a number or erase a number. So going on to the ALU, we've got our two 4-bit numbers that can come through and an option for subtract, which I'll get into a little bit later. Each of these have bitwise XOR, bitY AND, bitY OR. Fairly simple. The add subtract gets a little bit more confusing. Again, I built those multiplexers, and then we have a register 4, which is the same one from my register file. I just was able to use that. But these will determine which operation is going to take place. And then we have a clock coming through and a write enable so that we know whether or not we're going to pass that through back into the multiplexer. Okay, so we'll go ahead and look at the adder and subtractor in this case. Each of these has a full 1-bit adder here that goes through. The numbers come through into there, and then they can add into each other. And they have a carry out that goes into a carry in for the next one. And so to look at the 1-bit full adder, we just have a number that'll choose to carry out. The carry in can add a sum on there too, or vice versa. So it's self-explanatory there, I think. Going back out to the ALU, you can see, oh, actually the adder, not the 4-bit adder, I also have the option for subtract to come in, which is going to go into the XOR gates and initiate the subtraction. And that seemed to work fairly well without any issues. So going back to our main file here, we can go ahead and explain how we're doing the software subtract and the hardware subtract. So this code here, I'm going to go ahead and open. Where is it at? So basically what I did for the software subtract was I sent the numbers to, where is the full, the F? Um, where is it? I apologize. And here we go. So I did a full number here and a 3 so that I could put it into the ALU and then use the XOR gate. And then I brought in a 1 so that I could add the numbers together and so that I could get that, what's it called, the two's complement for it so that I could move it over to, again, add it together and then get my software subtract. And then after that, I was able to just do a regular subtraction using my subtract through the XOR gates and my adder, and everything like that again seemed to work fairly well. Have the numbers coming through. Like I said, I learned a lot during this final project. It was pretty fun to do. It made me want to go back and do a lot of the old labs that I struggled on. And so again, I'm Michael Wiltbank, and thanks for everything, Brother Davies. You've been an excellent help to me. I appreciate how I've been able to just continue forward on this with everything that was going on. All right, so that's